over 2 days. And so first of all, a random variable represents a numerical value assigned to an outcome of a probability experiment. We symbolize random variable with that capital X. And so we actually have two different types of random variables. The first one is a discrete random variable. And so if you notice what it says, a discrete random variable can take on a finite or countable number of possible values. For example, the number of accidents per year. Okay, number of accidents per year is a set number. Okay, you can't like have a decimal amount. Okay, so it's a finite or countable number of possible values. A continuous random variable, on the other hand, can take on an infinite number of possible values within a specified interval. So the number of miles driven. So notice that number of miles driven, it could either be like 2.1, 2.8, 2.7, 2.9930. Okay, so that's what a continuous random variable is. And so now what your task is going to be is able to identify if it's a continuous or a discrete random variable. So we're going to look at 3 examples here, and you have your expressions there. And so the first one, is this random variable discrete or continuous? X represents the weight of the cereal in a 15-ounce box of cereal chosen at random from those on an assembly line. Okay, so I need to know, is that a discrete or continuous random variable? Okay, it did send the one with you? Okay, A is discrete, B is continuous. So A is discrete, B is continuous. Okay, answer is actually B, it is continuous. Okay? Because you're not going to have like a set number, it's just going to be chosen at random. It's not going to be exactly like 15 or 14 ounces, it's going to be some value in between. So let's look at another one. X represents the number of cars in the school parking lot chosen at a random time during the school day. A is discrete, B is continuous. And the answer is A, because you can actually pick the number of cars. Okay, it's not like there's any decimal value or anything like that. It is a set number. So let's look at the next one, discrete or continuous. X represents the attendance at a randomly selected monthly school board meeting. A is discrete, B is continuous. Answer is A. Nice job. Okay, so A is, the reason why it's discrete is why? It's a set number of people. You can't have like a fractional person. Okay, you can't have like a decimal person. And so actually that is why it is a discrete random variable. So let's go ahead and look at this. This is taken from your book on page 665. It talks about a probability distribution. Okay, a probability distribution of a random variable is a table, equation, or graph. So real quick, probability distribution, table, equation, or graph. So it can be 3 things that links each possible value of X with its probability of occurring. It links each possible value of X with its probability of occurring. These probabilities are determined theoretically or by observation. So a probability distribution must satisfy the following conditions. First of all, the probability of each value must be between 0 and 1. And that should make sense. It can never be smaller than 0 or bigger than 1. The second thing is that the sum of all the probabilities for all the values of X must equal 1. So if we add them all up, we're going to get a total of 1. So those are the 2 conditions that must be satisfied in order for a probability distribution to exist. So now what we're going to do is we're going to look at actually creating a probability distribution. Not incredibly difficult. So, first example we're going to look at is as follows. On a teacher evaluation form, students were asked to rate the teacher's explanations of the subject matter using a score of 1 to 5, where 1 was too simplified and 5 was too technical. Use the frequency distribution shown to construct and graph a probability distribution for the random variable x. So the first thing we need to do, notice here are our scores. In the frequency column, I need to figure out how many forms were filled out, or how many students evaluated the teacher. So how many students did evaluate the teacher? There were 50 students that evaluated the teacher. And so now what I'm going to do is I'm going to go ahead and for each of these scores, I'm going to assign a probability. And this below is what a probability distribution looks like. Okay, so the first one, a score of 1. How many people rated this teacher with a score of 1? 1. So my probability will be 1 out of 50. And so what I'm going to do is I'm going to go ahead and simplify that a little bit. Okay, and I'm going to actually write that as 0.02. So 1 over 50 equals 0.02. So now the next one, what's the next one going to be for the score of 2? 8 out of 50, right? Which would be, what did you say? 0.16. Very good. What would 3 be? 20 out of 50, which is what? Yep, which is 0.4. What is 4? 16 out of 50, which is 0.32. And what is the very last one? 0.1. Okay, so now what I'm going to do, just to show that it is in fact a probability distribution, is I'm going to go ahead and add all these values up. So if you add 0.02 and 0.16 and 0.40 and 0.32 and 0.10, what do you get? 1. It equals 1. So that's how it works. Okay, that's a probability distribution. Any questions? Pretty straightforward. Okay, so now we're going to do the same thing with this one. We're going to construct a probability distribution for the random variable, rounding each probability to the nearest 100. So here we go, we start with this, right? Okay, and so I start with my cars, and then this one will be P of X. How many columns will I now have? 4, very good. So 1, 2, 3, I'm going to add another one right here. 4. Okay, so the cars here will be 0, 1, 2, 3. How many total cars, or what was the frequency for the number of cars sold? The frequency was 30. Okay. So let's go ahead and fill in the table. So what do I get? I get 0.6 repeating, which is not very good. Okay, so I get 0.6 repeating, which I'm going to round to the nearest hundredth, so it'll be 0.67. What do I get for 1? Because this is 20 out of 30. Seven out of 30, what is that as a decimal? Point what? 628. What? 0.23. Okay. What about the next one? What do I get on the next one? It'll be 2 out of 30, which is what?
0.07.
0.07. And then let's do 1 out of 30. What do I get? 0.03. Okay, now real quick. It has to be 0.03 because remember my total has to be 1. So I can't have it anything bigger than 1. So there you go, that's the probability distribution. Okay, questions? Pretty straightforward. Okay, now what we're going to do is we're actually going to learn how we can even extend this probability distribution even further. And so what we're going to do now, okay, is we're going to find the mean of the probability distribution. So we're going to find the average. So if you notice what it says this table shows the probability distribution for the teacher evaluation question from example 2. Find the mean score to the nearest hundredth and interpret its meaning in the context of the problem situation. So to find the mean, we're going to find the average. Now this is how we're going to find the average. Okay, here are my two columns, right? What do you think I'm going to do with the 1 and the 0.02? What do you think? What does the column say you're going to do? Times them. Okay, so this column I'm now getting 0.02. What am I going to do here? Times them, so what do you get?
0.0 or 0.32.
0.32. What do you get from this one?
1.2.
1.2. What do you get from this one?
13.8.
1.28. And what do you get from this one?
0.5.
0.5. So now what we need to do is find the mean. So to find the mean, this is what you're going to do. You're going to go ahead and add all those numbers up. Okay? So if I add all those numbers up, the 0.02, the 0.32, the 1.2, and the 1.28, if I add all those numbers up, I will get 0.33. So in the context of this situation, what does it mean when it's a 3.3? It means the teacher probably explains things pretty well. She's not too simplified and she's not too technical. Remember, 3 was in the middle. So anyway. Okay, questions? We got one more thing we're going to cover today, and that's what is known as the variance and the standard deviation. Okay, now the variance and the standard deviation, to find the variance of a probability distribution, we are going to subtract the mean of the probability of distribution from each value of x, and then we will square the difference. Okay, then we're going to multiply each difference by its corresponding probability and find the sum of the products. Once you find that, you can take the square root of that, and that will be the standard deviation. Okay. Now, the best way to do this is to see how the table is written. If you can understand the table, then you're going to be able to handle this just fine. Okay. So first of all, what did we find the mean from the problem before? What did we find the mean to be? 3.3. Now, you're going to probably wonder what that weird U is. That is another way to symbolize the mean. It's called mu. It's a Greek letter. Okay. So when you see that little lowercase u, that is actually known as the mean. So what this says in the problem is that you're going to take whatever the x value is, so in this case 1, I'm going to subtract 3.3 and I'm going to square it. So on the next one, what am I going to do?
2 minus 3.3.
Yep, and square it. Okay, now they're actually using 3.32. Okay, what do I do on the next one? And square it. Same on each of these. So all you're going to do is take that minus the mean and square it. And then in this next column, what are you going to do? You're going to take it times p of x. So in this case, I'm going to take 5.38. I'm going to take 5.38 times 0.02. So basically, you're going to multiply these. Oh, shoot. Let's undo that. I'm going to multiply these two columns right here. Good job. All right, so here we go. I'm going to multiply those two columns. And so when I multiply those two columns, these are the values I get. Okay. Now, what do you think I'm going to do with all of these values? I'm going to do what with them? Add them up. And that is going to be my variance.
What does it mean by the standard deviation is square root of the variance?
To find the standard deviation, okay, that's what we're going to do right now. To find the standard deviation, Okay, to find the standard deviation, I'm going to take the square root of 0.8576. What is the standard deviation going to be in this problem then? Because this is the variance.
2, 4, 3.
So what is
926.
0.926? So the standard deviation of this problem would be 0.93. Okay, so the variance is what you get when you add all this up. The standard deviation is going to be the square root of that. Okay. All right, questions? Okay, let's see what we got next. Okay, last thing we're going to talk about is expected value. Okay,
Add more into pizza.
expected value.
That's fine, you can't have all this.
Expected value actually just relates real close to what we got done doing. It's equal to the mean of the random variable.
Wait, did this help us win like the Price is Right?
What?
Did this help us win the Price is Right?
This actually helps you figure out if you're going to lose money or win money.
So we're pretty much learning how to count cards right now.
No, I don't really count in cards.
We're rigging the system.
Okay,
Like playing lottery.
so the first thing you're going to do when you figure out expected values, you're going to figure out your gain. Okay, so if you notice this, it says at a raffle, 500 tickets are sold at $1 each for 3 prizes of 150 and 10. What is the expected value of your net gain if you buy a ticket? So the first thing you're going to do is you're going to start with all the prizes. Okay, you have a prize of 100, 50, 10, and you also have a price of our winnings of 0. So what I'm going to do here is I'm going to go ahead and plug all those in. Now notice what I have to do is subtract off my $1 entry fee. So I have to subtract the price of the ticket. So really my gain on the first one is 99, 49, 9, and negative $1. Now what I'm going to do is find the probability of each of those. What is the probability that you win the $100 prize?
1.005.
The probability that you win the $100 prize is 1 out of 500. What's the probability that you win the $50 prize? 1 out of 500. What about the $10 prize? What about nothing?
497.
497 out of 500. So now to find your expected value, what we're going to do, notice what it says. I'm going to take each of these times themselves. So I'm going to take 99 times 1 over 500, and I get 99 over 500. Okay. The next one, what do I get? 49 over 500. What do I get here? 9 over 500. Oops. And what do I get from that last one? 497 over 500. So now if I add all those up, that will be my expected value. So what is 99 plus 49 plus 9 minus 497? What does that come out to be? Negative 340? Did somebody else get negative 340?
Yeah, I can do it.
So if you take negative 340 and you divide it by 500, what do you get for a decimal?
Um,
So your expected value, if you were to participate in this raffle, is that you will lose 68 cents.
Can we try this for negative?
So that's one of those things you can actually figure out your expected value, like if you were going to play the lottery. Your expected value probably when you play the lottery is going to be a lot less than that.
I think we all know.
Yeah. So anyway, here's what you need to do. Page 670, 1 through 12. We'll continue. No, this is a new assignment. This is section 2.
Can't we put it on the back of this one so we
No.
can see it on Monday?
This one, the thing is, you're going to add to this 1 through 12. Okay? 1 through 12 is section 2. So